Okay, so these are the last three questions of the 2019 exam. And they weren't easy. I remember this last year. The kids were saying that they were just difficult. Um, my gut tells me that they really can't make it this hard on May 12th because it's very specific. But you have a cylinder for number 4, again, no calculator. And with every related rates question, you have to put the radius into the equation first. It's not like a cone problem. So by doing that, you get the volume of the cylinder for this problem is pi h because the radius is 1. And then when I take the derivative, I get pi dh dt. And they want the rate of change of the volume when the height is 4. So then I'm just going to put dh dt in. And again, that's given. You put 4 in for h, and you multiply it through. Again, no calculator, you can do this. And don't forget the units are cubic feet per second. I thought that was a pretty straightforward question. Letter B was the hardest of the three parts, if you will. Think of it like an implicit differentiation problem where you're trying to find the second derivative. In order to find a rate of change of the actual dh dt, you have to take the derivative of dh dt. And when you derive, you include dh dt. So the second derivative is going to be the derivative of dh dt times dh dt. And again, you could practice that looking at this cross here. This was a pretty hard problem. I would say that my students probably struggled with this part last year. And then you know that dh dt is negative from the beginning of the problem, and you know the second derivative is negative, so the rate of change has to be positive because a negative times a negative is positive. So that's how I answered that. The good news about this question is part C, you don't need anything to do with part B. So I think that that was the olive branch here. It's a classic separation of variables problem. So this is a good review question for you. For how to do this. I would really focus on differential equations for next month. But again, you set it up. This is the original dh dt. And I cross multiply to get the h's on one side and then the constant with dt on the other. Remember, dh over radical h is h to the negative 1/2 dh. And now integrate both sides. And this is a very traditional problem. And I would imagine my students did well on this. Follow the paper here and you'll see it. H of 0 is 5. That's the initial condition from the problem. I would solve for C now. I think I've taught that when I did this topic with you. So solve for C. T is 0. H is 5. Resubstitute. Divide by 2. And then you'd square both sides to get H alone. So I thought that was a pretty good problem. This was a kind of a standard question. Again, I would hope that you could get the part C and the part A for this question. Number 5 was probably the most traditional of the three. They gave you a picture of the solid, and the question A is they want you to find the area. Now, the hardest part of this problem is that you get a point for writing the integral, and then, once you start substituting it, you're going to find it to be a little tricky with no calculator. So let's just remember a couple things. X minus 1 squared is x squared minus 2x plus 1. So when I simplify that parenthesis and subtract the negative 2, it will work itself out. So if you want to follow my work or hit pause and follow the work, you will see how I get the answers. Pretty straightforward at this point. So see if you can get to this point, if you have to pause it. And then when you substitute the 2 and the 0, you should get 44 over 3. That was that's a good question. I wouldn't put that as a hard question, but I would definitely practice this to make sure you're getting 44 over 3, because I think that's a question we can all get right. Question B, that's a cross-section problem. The area of each slice is 1 over x plus 3, so the volume is the integral from 0 to 2 of 1 over x plus 3 dx. Nothing squared, no pi, nothing. Okay? And then that's in ln. remember this would be essentially dx over x plus 3. My u is x plus 3, and my du is dx. And the integral of du over u is the natural log. I don't need absolute values because 0 to 2 is positive. Substitute. It's the ln of 5 minus the ln of 3, not 0, or undefined, if you will, because when you put the 0 in, 0 plus 3 is 3. Anyway, I thought that was a question that was attainable. Question C, it's a volume question revolving around the line y equals 6. This should make some sense to you. And I did suggest, as in the past, I would use g of x and h of x here. Otherwise, you're going to have to rewrite these tricky functions with the signs, and it might be a little tricky. You don't have to evaluate. They just said write the integral. It's a pretty standard question, and I thought that this was a question we could do well on. Clearly, number 6 is the hardest one of the three for this year. It doesn't mean that number 6 is the hardest every year, but this case, I think it certainly is. But they give you a bunch of stuff about F, G, and H in this problem. And again, you're probably going to need a lot of this, if not all of it. Question A is, what is H prime of 2? And the answer is 2/3. And this might have snuck past my students last year, but they gave you the tangent line in the problem, and they told you the slope was 2/3 in the tangent line. Again, refer to the question to know that. They just wanted you to to identify that the slope of the tangent is H prime of 2. So anyway, I hope you got that one. But I could see students not getting that because it kind of could slip past. Question B was probably the mechanical question that they want you to get. If you're looking for partial credit, you got to get these early questions right. A of x is equal to 3x cubed h of x. So by the product rule, a prime is 3x cubed times h prime of x plus h of x times 9x squared. And that's by the product rule. And now you can substitute 2 in for x here. H prime of 2 is 2/3. H of 2 is 4 from the given in the problem. And it should work out to 160. That was probably the mechanical part that I think people should get right. Question C I thought was really hard. And again, we don't have to get every question right. Just like in question 1 from this year's exam or last year's exam, they tell you it's differentiable, so that's assuming that they're continuous. Remember, differentiability implies continuity. So if they don't tell you that, if they tell you it's differentiable, then you know it's continuous. So again, my writing might not be the best if you need to consult the answer key, but what I decided to do is I said, okay, the limit as x approaches 2 has to also be 4, because if they both go to 4, then so does h of x. And whatever h of x was given in the problem, I took the derivative, because by L'Hopital's rule, you have to be 0 over 0. So I took the derivative of the h of x, which was given in the problem. And again, the derivative of f of x cubed is 3f of x squared times f prime of x. That's the chain rule. So you want to take a note of that. But this is the derivative of h of x, so keep that in mind. Now, you know that you have to set both the numerator and denominator equal to 0 in order to get 0 over 0. So I don't know I know that x equals 2 and negative 2, if you will, it satisfies the numerator, which gives me the 2. But now I got to set the denominator equal to 0. So I know that f of x cubed has to equal 1, all right? Now I know that f of 2 has to be 1 because 1 cubed is 1. So that gives me f of 2, which I would put into here, all right, for the derivative. 2 times 2 is 4. F of 2 is 1. 1 squared is 1. 3 times 1 is 3. And if I cross multiply, I could solve for f prime of x, which in this case is 1/3. So f prime of 2 is 1/3. That was a pretty hard problem. I'd venture to say that was probably the hardest question in this year's test for 2019. And question D, if you identify it that you, and again, I think a lot of people probably got this right. You're using the sandwich theorem or the squeeze theorem. And if you remember that from way back in September, you have two functions that go to the same limit. You can squeeze another one in there. So the AP graders are looking for sandwich theorem or squeeze theorem to say that the limit as x approaches 2 of k of x also is equal to 4. And that also shows continuity that k of 2 has to equal 4 because they told you that g of x was less than or equal to k of x less than or equal to h of x. However they did it, the fact that it's less than or equal to implies that k of 2 is 4, which shows the continuity because the limit exists and the function exists. Probably a lot of my students might have forgotten that at the time. That's the first time I saw an AP question asking about the squeeze theorem. I don't think you'll see that next month.